Let's take a look now at 13. So 13, during a scouting exercise, Ramiro leaves camp and hikes 3 miles on a bearing of 10 degrees. He then hikes 2 miles on a bearing of 110 degrees. Based off this information, approximately how far is Ramiro from his starting position? All right, 6 types of problems. What type is this one? So I got 1 vote for vectors. Does it say the word vector? So how do you know it's a vector? There's a direction and a magnitude. There's actually 2 directions and magnitudes. And so what vectors do, as we've learned throughout the years, vectors all add together. And so this is a vector problem. And before we get started, I want you to know this is one of the lowest scored questions we had. Only 39% of students got this one correct. So it is one we can certainly work on. All right, with vectors, there are 2 things I would highly recommend you write down. When you take this, to have a sheet of paper and to write 2 things down, and then we'll use our calculator to get our final answer. One is an X and Y axis. Highly recommend that. What's the other thing? Can you tell me what's the other thing we should write down? Yeah, what kind of chart? What do I call that thing? I call it a tic-tac-toe. I might call it a T-chart. I might call it a 4x3. Yeah, I heard both T-chart and I heard 4x3. Yeah, let's go ahead and fill this out. Okay, so to label, over here, they did not say X and Y. They did not say anything. They said just angles. Because they did not say north, south, east, west, anything like that, I'm just going to go ahead and put X and Y here. Because they didn't use the words northeast, southwest, I'm just going to leave it as X and Y. They tell us the first one is 0, 10 degrees. Now, whenever they do a 3-digit number like that, that just means you start from a standard position, meaning you start at where a 0 normally is, right here. We start from 0. So let's draw our first vector. I'll do it in blue. First vector, it's 10 degrees. So tell me when you think I've traveled 10 degrees. There. All right, it's not too far. Let's just go like that. I'm gonna make it a little bit shorter so I can fit in a second. So there's the first vector, and it's 3 miles at 10 degrees. That's 3 miles. Okay, and then what happens on the second vector? 2 miles. So it's 2 miles at 110 degrees. Okay, so here we're starting over. So this is a brand new spot. So how many degrees would it be if I made it like that? 0. So tell me, how many degrees is it to there? That would be 90. And so I need to go about 20 more. Would y'all say that's about 110? Okay, so we're going to say that's 110. Now, just to make sense out of this, I'm going to add a little dash line here from here so I can see where the new 0 would be. If that's also 0 degrees, then the second one, I'm just adding this so we can see it later. This would be 110 degrees. Oh, I see I forgot to label 110. And I forgot to label this one as 10 degrees here. And this would be 2 miles. So that's our drawing, except for I would not get credit right there if I was looking for a picture. What's wrong with that drawing?
There is no displacement that far.
What's the correct word I use? There is no. Starts with an R. Resultant. We need the resultant. That means from the start to the finish. You need to add a resultant here. This one would be our resultant. And I'm gonna, whoops. What I am gonna do is I'm gonna fill it in so I'm not distracted by 2 dashed lines. So I'm gonna cover this up. Yes, ma'am. Okay, so there's our diagram. Our diagram's now finished. Now let's go over the T-chart. Make sure we fill this in correctly. What do I put across the top? X, Y, H, theta. Now on the sides, after we label X, Y, H, and theta, I usually do 1, 2, R. So the first one's blue. Where am I? There we go. 1, 2, and my resultant I drew in black, so I'll do that in black again. All right, let's talk about this first blue vector. Does this appear to you to be a x-axis, a A y-axis or a diagonal h? Diagonal h, I agree. We had the value of being 3 miles. Right there, it was 3 miles, so that is our h. Our h is 3. Let me put this in blue. 3 miles, and the bearing, it's coming from standard position, so it's real easy. All we're gonna do in the calculator is do angle 10 degrees. Angle 10. You could do 0, 10, but 10 is fine. Okay, what about vector 2? When you look at vector 2, does that look like an x-axis to you, a y-axis, or a diagonal h? Again, it's a diagonal h. So we put that the value of 2 as an h, and for the angle, 110 degrees. Notice I use the angle symbol here because that's what the calculator needs to add these up. Now, vectors always do what? What do vectors always do to each other? They add, they subtract, they multiply, they divide. They're going to add. For the sake of pre-calculus ACP, they're going to add. Okay, so that's. Okay, so as we were saying, vectors always add. For the sake of this test, vectors always add. So let's pull up our calculators. First thing, make sure, what mode are we going to stick in? We're just going to stick with radians. Since we're sticking with radians, we need to make sure we type in the degree symbol. So first, where do you find the vector button? Or how do you enter in a vector into the calculator? Control parenthesis. You need to remember that one. Control parentheses. So we do 3 comma. Where's that angle symbol? You can press book. If you want a shortcut, if you press control book, it'll go to the 4th page where it's actually at. Press control book, it'll jump straight to that 4th page. So it's the 4th page that looks like that. So control book takes you straight there, and you'll see that angle. It's 3 and then 10 degrees. Don't forget to put the degree symbol. You can find that in with pi. All right, and one more time, what do we say vectors always do? Add. So go outside that vector, hit a plus, control left bracket, and we have 2 comma. I gotta do the angle symbol again. Where do I find that one more time? Control book, angle symbol, 110 degrees, and then one more time, put that degree symbol there. All right, when we press enter, what values do they give us as the answer or the resultant? What values of the resultant do they give you? All right, y'all answered both ways. You said the exact values, 2.27 and 2.4, and then Andrew says what the values actually represent. They represent x and y. This is the x and y of the resultant. The resultant is 2.27 units to the right, and it's 2.4 units high. That's where this point right there would be located. That's what we just solved for. That's 2.27, and this is 2.4. Now, this problem doesn't ask for that. It says approximately how far is Ramiro? Approximately how far? What would that be? Would that be the x value, the y value, or this diagonal resultant? If we want to know how far Ramiro is from camp, it would not be the x value. Would not be the vertical value, the horizontal nor the vertical. It would be the diagonal value. We need to know the magnitude. How do we get the calculator to tell us that? Menu 7 C for vector. So menu 7 says matrix and vectors. C says vectors. Convert to polar. Hit enter. You'll have your answer. Now notice this is in radians. So if you needed a degree angle, we'd have to work on that. But it's 3.3 for the H. And in radians, the angle is 0.8 in radians. So the answer would be B. All right, number 14. It says given vectors M and N, which graph represents the vectors, the addition of vectors M and N? So here they don't use the vocabulary. They should use the vocabulary resultant. They don't. They just say which graph represents the addition, but that just means the resultant. What type of problem is this? Yeah, it says vectors, and the addition of vectors means resultant, by the way. That's what that word resultant means. We're going to add up vectors. So this is more or less when you get out of the 5 problems that are vectors, there are 5 that are vectors. Oftentimes, you're not going to have to do everything like we did on 13. It might be something like this. So here, it says vector 4, 1. What would that look like if it was 4, 1?
4 to the right, 1.
Perfect. 4 to the right. I'm going to use answer choice A. 4 to the right, 1 up. And the second is 1, 7. Now I have a question for you. How are you supposed to graph vectors? Tip to tail. So the second one, would I graph it from here like they did on A? No, what you'd be looking for is a tip to tail like this. That means one more to the right, 7 units up. And then finally, to get our answer, the graph will not only look like that, what will it also have? A resultant. It goes from start to finish. Whoops, I meant to use different lines. Sorry, let me try this again. It would go from start to finish. Okay, so which graph was that? B. B is the correct answer here. And students got that one correct. Are you ready for this? 23% of the time. That was it. 23% of the time. Answer choice A was selected 62% of the time. Now, why? So if you go around the room, that means many of you selected A. Why do you think we selected A? Did they do tip to tail? No, what you did is start at the origin. Is that how we do vectors? How do you do vectors? Tell me again. Tip to tail. Tip to tail. So it goes this way. So that's why A was selected. Remember, go tip to tail, and it's very simple from there. All right. I believe that was the lowest scored test question on the entire test. Yeah, looks like it. Let me check the last one here. Yep, that was the lowest scored question. 15 says a spinner on a board game has a radius of 3 inches and spins a circular region as shown in the on the figure. The center of the circular region is the origin, and the spinner's initial position is on the positive x-axis. Rachel flicks the spinner, causing it to rotate 600 degrees. What are the coordinates of the tip of the spinner when it stops? Now, this one might be a little bit trickier for you to figure out what type of problem this is. But it is one of those types of problem. Which one would this fall under? Yeah, I would put it under polar. Now, technically, it might go under analytical trig, but I would put it under polar because what? What are you seeing? What are you seeing here? A circle. Now, how did I tell you to do polar the other day? Desmos. So let's go to Desmos. So I already have mine in from last. How do I get the, let me go back to the way you're going to see it. When you load it today, brand new, you're going to see it this way, rectangles. How do you get it to polar grid again? That's the key to Desmos. You need to change it to the polar grid. Wrench, grid. The one that looks like a spider web is polar. Okay, now, right now, this is in pies. Are we in pies? This is in radians, I mean. Are we in radians, this problem? We're in degrees. How do you switch to degrees? Say wrench again. Wrench again. All right. Go in the wrench and you'll see it at the bottom. It says degrees there. So as I look at the degrees, what's the problem with 600 degrees? It's too big. So how many do we need to take away from 600? So 600, if we take away 360, what are we left with? 240. Okay, so here's the question. Which of these points would be on the third circle? Third circle, because it's a radius of 3. Third circle at 240 degrees. So here's 240 degrees, and we need to be on this third circle. 1, 2, 3. We need to be right there. So let's just start typing in the points. Let's try answer choice A. -3/2, comma, -3 square root of 3, all divided by 2. Now, does that look like a good spot? Looks like we might have found the answer already. Looks like it might be A. A looks pretty good. By the way, this question was correct only 46% of the time. By the way, we chose polar because it was a circle. So let's just check. That looks like it's third circle at 240. That looks pretty good. Let's check the other ones here. If I just change this is 3 square root of 3. doing B now. Answer choice B over 2, comma, -3 over 2. Does that look like the right spot? What's wrong with this one? That 210, so that's not it. You could try C, 1/2, and then negative square root of 3 over 2. What's wrong with answer choice C? Wrong circle. It's on the first circle. What circle are we supposed to be on? 3. Yeah, so the answer choice is going to be A. 3 squared is a 3. That puts it on the right spot. The diagram here in number 16 shows a boat that's anchored at point B in a river. There are 2 boat ramps on the far side of the river as shown by points A and C. The boat is 120 meters from ramp A and 150 meters from ramp C. If measure angle ABC is 110 degrees, what is the approximate distance between the boat ramps to the nearest meter? All right, what type of problem would you say this is? Yeah, it's a triangle problem. Looks like a triangle. It is a triangle. All right, how are we going to solve this triangle problem? Take a look. I'll do a countdown. What technique would you use for this one? 5, 4, 3, 2, 1.
Law of cosines.
Why cosines?
So we don't have a set.
No set. So this time I'm going to draw what would be the set, the question mark and the 10, and I'm going to write down cosines here. Let's go to the formula chart and get that law of cosines because we don't use this one as often. So let's go grab that formula. Where is my formula chart? There it is. Law of cosines. Here's law of cosines. I'm going to pull this one formula. There's 3 of them. Technically, what am I solving for technically? The B. So I'm going to choose this one. Not that it really matters, but I'm going to choose this one because you always do the set. Cosine finds the set, so I'm looking for little b. I'm going to use this one. Okay, so let's copy down that formula. It was b squared equals a squared plus c squared minus 2 ac cosine b. Let's plug in what we know for our insolve. Do we know little b? No. Do we know a, little a? What's little a? 150 would be, technically, it doesn't matter that much, but it would be 150. What about little c? Okay, what about a? What was that again? 150, and then C. 120, and finally, capital B. And don't forget to put the degree symbol. So go to your calculator. Let's insolve this one. How do I do insolve?
Our variables on there.
You're right. You don't have to insolve this. You could just, what's the opposite of a square? You could just square root the whole thing. I'm going to just, since I started insolve, I'm going to go ahead and do it. B squared equals 150 squared plus 120 squared minus 2 times 150 times 120 cosine of 110. Don't forget the degree symbol. Come on, B. All right, Vincent, make sure you're doing this, please. Alexander, make sure you're typing in, please. That might be true, but I want to see you do it. 5, 4, 3, 2, 1. What are you getting? 221.8, and it says round to the nearest meter. So 222 meters. 222. 222 meters would be the answer. All right, great. Number 17 says, which equation represents the hyperbola with foci at those 2 locations and a transverse axis that is 8 units long? All right, which of the types of problems would this be? Why conics? What do you see? Yeah, if it says hyperbola, it's going to be a conic section. Now, conic sections, you need to know your vocabulary for 2A, 2B, and 2C. You need to know that. So in this problem, it says foci. What is foci? 2A, 2B, 2C. 3, 2, 1. 2C. Perfect. The other thing you need to do is figure out what letter that would be attached with. What's changing? The X. Now, that's not as important with foci, but it does. I'll point out in a second why it matters. It's X. Okay, so we go from -8 to +4. I want you to think about what's the distance between -8 all the way to +4. 12. So 8 one way, 4 the other way. You add those together. 12. I agree. 2C is 12. Now, here's a big trick for you. Not only should you ask yourself the question, what letter is changing and by how much, you should also find out what that variable is squared, because A, B, and C, you're always going to want to square them, just always for the formula. Now, I'll show you what that does in a second. How do I get C isolated? We divide by 2. And so what does C actually equal? 6. Now, A, B, and C, you're always going to want to square them. What is C squared? Now, go to the formula chart with me, please. And on conic sections, this, what shape is this? Whoops. Clear that off. We are looking at hyperbola. Now, we'll be able to figure out which equations used in a second, but I just want to start the obvious. Look at both formulas that you have for hyperbola, both of these two. Do either standard form equations include a C squared? No. So frequently, you will see distractors that include C squared. We know what C squared is. Should that be included in the problem? No. So which ones can I eliminate based off C squared? A and B. A and B are gone. So it has to be one of these two. It shows me that the x squared is going to be positive first. If we have all that, you could go off of this, the lie, but these both have the lie on them that shows the y as being +3 and it has y -3. So can't solve the question there. So I need to move on. It says the transverse axis is 8 units. What is transverse? 2A, 2B, 2C. 3, 2, 1. Ooh, that's wrong. It's not 2B. It is 2A. Transverse is 2A. So now that we know 2A is 8, how do I get 1A? Divide by 2. So 1A is 4, and A squared would be 16. I'm going to go to the formula chart. The A squared, to figure out where does the A squared go? And the equation that has a positive x fraction and a negative y fraction is this first one. It's not the second. It's this first one. Oh, and I forgot to say this with foci. Let me finish the problem first. The one that has the x squared being the positive fraction and the y squared negative, like our two options here, that formula has a squared under x. So 16 has to be under the x. Which one's the correct answer? 16 has to be under x squared. So the answer is D, this one here. So the answer is D. The 16 is in the wrong location. By the way, this one was only scored correctly.
We did see the last one.
Oh, I did not, did I? 58% of the time. 16, believe it or not, is low. 49%. Only 49% got that right. Okay, on 17, one thing I forgot to tell you. So go back to foci. Foci changed which letter? X. I meant to tell you this earlier and I forgot. When you go to the formula chart, you see how it has foci listed there? The two foci, when you look at them, this 2C's here is represented by a positive C and a negative C. This 2C, which value are they changing? Is this changing the X or the Y? That one's changing y. What did our c's change in the problem? Do you remember? Let me show you again. What did the c's change? The x's. So it would be this problem because here the c is changing the x value. That's the x, that's the y. The c's, the two c's are changing the x. And that was another reason why you could have known it was that formula. I forgot to tell you that at the start. Number 18, Monica and Ruby are rowing their kayaks towards the same dock as shown in the diagram. Based on the information in the diagram, which conclusion is true? Monica is 30.47 feet closer to the dock than Ruby. Ruby is 30.47 feet closer to the dock than Monica. Monica is 9.02 feet closer to the dock than Ruby. Ruby is 9.02 feet closer to the dock than Monica. Which type of problem is this?
Triangles.
This is a triangle problem. It's a triangle problem. Now let's solve this triangle. I see I have two angles. Could I figure out what the angle is here? How? All triangles add up to 180. So let's go to our calculators to find out how many degrees go in that bottom angle. So it's going to be 180 minus 34 minus 31. 115? 115 degrees. By the way, before I forget, this is number 18. Students got this right 50% of the time. That means half of you got it right, half got it wrong. Okay, are we going to use law of sines or law of cosines, Daisy? What do you think? Sines. Why sines? Do we have a pair? What's our pair? 185 and 115. Perfect. So that means sine of 115 degrees divided by 185 will equal either of the other two pairs. So I'm going to set this. Which one do you want to solve for first? The side across from Ruby or the side across from Monica? Monica. Okay, let's find this one here. I'm going to do a little m. So that would mean that sine of 34 over m. I'm going to end up moving this here. Okay, so let's go and solve this. Menu 3-1. So we have sine of 115 degrees. Don't forget the degree symbol. 115 degrees over 185 will equal sine of 34 degrees. Again, do not forget the degrees because we're in radians. You put that symbol there. Over Monica. I don't know. All right, Jennifer, did you already type it in? Can you type it in for me, please? All right, what'd you get there, Melanie? All right, I agree. I got 114 point. They use two decimals, so I'm gonna say 114.14 or 0.15.
115.
Let's go 114.15. M is approximately, so I'll do the curly equals 114.15. Now I could do the same thing, but now let's solve for Ruby. Ruby is across from how much? 31?
Yeah.
So I could do the same thing. I could do sine of 31 degrees over Ruby. So I'm going to go to the calculator and just copy this and only change the right parentheses. I'm not changing the left parentheses. That's still my completed set. I'm now going to say sine 31 over R for Ruby. R. And then R here. So I just copied basically the whole thing. All I'm doing is changing the second fraction from sine 34 over M to sine 31 over R. Press enter. What are you getting now? 105.13. Okay, so this is now, we're saying Ruby is 105.13. Okay, so we need to know which one is closer. So I'm going to take, we'll subtract here. It's 114.15 minus 105.13. Okay, it's 9.02, which eliminate which two answers? Okay, if you're thinking of distance, which one's closer, the bigger distance or the smaller distance? The smaller. So this one's closer. Ruby is closer because it's a smaller number. Ruby is 9.02 feet closer than Monica. That would have been the correct answer. Why is Monica closer? Didn't Ruby get a smaller number? And so wouldn't a smaller number be closer?
Yeah, the answer is D. That's what the answer said. Yeah, that's what school city says.
Oh, well, the correct answer is actually D. Okay, towards the dock. Based on the information, which conclusion is true? Ruby is closer to the dock than Monica. Ruby is closer to the dock than Monica. This is a shorter distance. This is 105 point. Oh, wait a minute. I see why this is tricky. Yeah, it's 50 still. I should have wrote it in. This is what I get for not writing it in. This over here is 114.15. Now here's why I got confused, because I use M and R down here. But when you look at it this way, how far is Ruby away from the dock? Yeah, so I used an R there, but this is actually Ruby's distance, 114. This is Monica's distance. Monica is closer. So, well, I didn't make 100. So yeah, it is, Monica is closer than Ruby. Yeah, I guess if you get a problem like that, let's make sure we write in the numbers on the diagram and not go off the letters we use down here. So that's what confused me, is I used the letters and I was just saying, okay, this is Ruby. This is the closer number. However, that's not Ruby's distance. That is actually the distance of Monica to the dock. Interesting. Glad we looked at that. Okay, so that was number 18. Number 19, a trig expression is shown. Which is the simplified form of this expression? Oh no, I lost my deal. What type of problem is this one now? Analytical trig. That's right. Now on analytical trig, this is the one I say you a lot of times need to know some information. This is one that you don't actually need to know information. How could we get this correct? Just graph it. Which way do y'all want to graph? Desmos? Okay, go open up your Desmos then. Want to do it by Desmos? Wait, when you said just graph it, how will you know which one's the correct answer? Sharing graphs. Okay. You don't have to have a polar grid. You can, you don't have to, it doesn't matter. I'm just going to go back to a normal grid. It doesn't matter what you have. The first equation they give us is 1 minus sine x. Oh, I need to make sure on the test you won't have to worry about this. It'll automatically reset. I'm going to go back to radians. You always graph in radians, always. Parametrics are the only oh, I don't want to do it this way. In case you're using Inspire, what do you do with the power? Do you remember? Put it after the variable, and if you use the trig functions over here, I should have done this. Let me start over. I'm going to retype it in. What I would recommend you do is whenever you go to type in the trig, don't actually type in sin x, just hit those functions and it's right at the top. Do it like that because that'll help the calculator with the parentheses on the variable. I should have done it at the start. So there's my first parenthesis, got it in. Second, 1 plus, again, for sine, I'm going to hit the functions and then type it in. And then last parentheses, functions tangent x. Now, what do we say to put the power? Behind. Now, Desmos will do it just fine if it's a squared, but just to be safe, just memorize it, put it after the parenthesis right there, after the parenthesis. Okay, so there's our value we're looking at. Now, would that be the graph of 1? No. How do I know it's not 1? Because that would be a flat line. I'll type in y equals 1. Notice that's not right. It's not 1. So let's keep trying the other ones. If you know which ones are waves, it'll be a head start. So I'm going to try answer choice B. Would it be tangent squared x? Tangent x squared. Is that it? No. So let's now try. So we know it's not A, it's not B. Let's try sine. Could it be sine squared? Yeah, it's sine squared. There you go. It's sine squared. So just remember to put the powers after. If it's a square, Desmos will handle it in a normal spot. My Inspire will not. The Inspire only works with the powers after the parentheses, just so you know. Okay, this was correct 68% of the time. 68% of students got this one correct. Number 20, during a cross-curricular unit in our art class and math classes, Fabiola used a polar equation to produce a rose as shown in the grid. Which polar equation did Fabiola use to recreate the rose? Which type of problem do you think this is? Polar. Why do you say polar? It says it. It says polar. So on this one, is there any shortcuts you know of that we could take here? You could graph in Desmos, absolutely. I would recommend that. But I mean, to eliminate any answer choices, if you count the circles, the maximum is on the 4th circle, which means where do you put the maximum? The front or the middle of the equation or the front of the equation? The front. It has to have a maximum of 4. So it's going to be one of those two. Let's go ahead and graph and figure out. I already have Desmos up. This will be great. I'm going to switch to polar just to make sure. Switch to polar grid. R equals 4. I'm going to press functions for sine 5 theta. Where do you get the theta button on polar? ABC. It's under P to the right of L. Above the delete. Is it the sine function? No, which means it must be cos. I try cosine. Does that look right? Yeah, it does. It does. So the answer is C. This one should have been really high, and it was 94%. Students got that one right. 94%. Number 21. Which graph represents the curve given by the parametric equations x equals 4t plus 2 and y equals negative 2t squared plus 6 over the interval negative 2 is less than or equal to t, which is less than or equal to 2. All right, what type of problem would this be? Parametric. How'd you know parametric?
T.
It shows a t, and there's another reason. It says it right there. So yeah, parametric means there's time involved or a t. All right, how do you think we'll solve parametric? Inspire. By the way, there are, just so you know, there are 2 bogus answers in here that can never be true. Look at answer choice A. The arrows are moving, would you call this clockwise or counterclockwise? Okay, can time go from starting at +2 and move backwards in time to -2? No, so A is not a legit choice. That is a bogus choice. And there's one other one that's bogus. What's the other one that's bogus? Ooh, I don't think it's C that's moving from -2 to +2. D is moving from +2 to -2. So these 2 are bogus. So it's going to be one of those 2 graphs. We just have to figure out which way is the graph moving. So you told me go where to do parametric? New document. I'm not going to say. Go to graph. 3 for graph entry. 4 for parametric. Good. Don't be surprised in the test if they mix up the order of the x and y. Just make sure you put in the x equation as x. It does not the first equation, it's the one that has the x. Make sure you did the x equation is x, the y equation is y. This one they gave us a very specific time. What time did they give us? -2 seconds to +2 seconds. Now that will shape the graph. I messed up somewhere. I didn't forget. Forgot the square. What gets squared? -2t squared. There we go. Now I'm getting the right graph. Okay, how do you know which way the arrows move? Menu, trace, graph trace. Okay, when I press the right arrow, this is moving clockwise or counter? Clockwise. So the correct answer is B. Let me get the stats on this one. The stats are, this is number 21, 69% of students got this correct. So that wasn't even a passing grade there. 22, what are the rectangular coordinates for the point 5, 5 pi over 6? All right, this one, I wonder if it tricks you or not. What type of problem do you think this is? It is a polar problem. Does it say the word polar? No, this right here is a polar coordinate because it's a magnitude in a direction. It's a, you could say a radius and a theta. That is polar. So how do we do polar problems? Desmos. Okay, so here's how we will do this one. I'm going to clear this graph off. You want to make sure you're in a polar grid. So when you're on Desmos, every time when you're taking the test in School City, every time you go to a new problem, it will clear your graph and start you fresh like that. So how do you get it into polar grid? Wrench. Hit the wrench. Grid. Not only that, it'll also always start you in radians. Is this in radians? Yes. Okay, so we know we're on 5 pi over 6, and it's supposed to be the fifth circle. Now, I want to make sure you know this. If you just type that in, it will not graph it like that. So Desmos will not. Let me just show you. Does it graph that point correctly? No, it doesn't know how to plot the point. You just need to know where the answer is supposed to be. The answer is supposed to be on the fifth circle right there. That's the answer we're looking for. Now, we could probably take some guesses on what do you think the x should be? If it's supposed to be right here. Is the x supposed to be positive or negative? I'm hearing positives and I'm hearing negatives. Is it to the left or the right? To the left. So we need to have a negative x. So I'm going to start with A and B. Okay, so which one do you think is a better guess if there's the point? What would you guess the x is roughly? So count the circles. 1, 2, 3, 4. Would you say about 4 point something? Which one of these do you think is going to be 4 point something? You all don't know. Let's just go with A then. It's going to be A. I can just tell you right now, it's going to be A. That is negative 2.5. It's not that. I know that looking at it. So we go -5, square root of 3. Please be graphing with me. Vincent, are you actually graphing with me? Over 2, comma, 5 halves. Did that plot the point in the right location? I hear roughly. Does it look like it's the fifth circle?
Yes.
I think it's perfectly on the fifth circle. Is it on 5 pi over 6? Answer choice A is the correct answer. This was selected 81% of the time correctly. So a lot of students did that correct. Now, if you don't think of that, you can always, I just want to remind you of this. You can always use sine y, cos x, tangent is y over x, and the Pythagorean theorem, x squared plus y squared equals h squared, and then solve those. One more time. You can use sine y, cos x on any problem, not just this problem, but any problem. If you get stuck somewhere, tangent is y over x, and then x squared plus y squared. That's wrong. X squared plus y squared equals h squared. If you ever break down, you can use these and solve. So on this one, Eduardo, what did they give me up here? Is this an x, a y, or an h and a theta? That's an h and a theta. So if they gave you h and theta, pick equations that include h and theta. So does this include h and theta? Come on up. Yeah, please. Does this equation down here give you an h and a theta? No, you wouldn't use it because it doesn't have an h and a theta. Does this have an h and a theta? No, it has a theta, but no h. So we wouldn't use those. You would use these two equations. You could solve and get x and y from them. Okay, so if you ever break down on that, just go back to good old faithful sine y cos x. If you can't think of how to do it, that's just an extra technique. Number 23. It says an ellipse has the given characteristics: a center at the origin, horizontal major axis of 16, eccentricity of 0.25. Based on these characteristics, a portion of the equation of this ellipse is shown. What number completes the equation? What type of problem will this be? Why do we say conics? What word are we seeing that tells us conics? It says ellipse. So this is conics. You will have 5 of these problems. You need to know your vocabulary. What vocabulary do they give us in this problem? Major axis. Now, what is major axis? 2A, 2B, 2C, 3, 2, 1. It is 2A. Now they tell you it's horizontal. What does that mean? It's going to be the x changing. So in our equation, the x squared and the a squared are going to be partnered up. Now, why do I know that? Because everything on the formula chart, remember, I'm switching modes here. I'm not teaching you how to write equations now. I'm in the mode of let's make sure we get the right answer. Everything for ellipse and hyperbolas, if you look at the equations, everything is squared. So as far as the equation goes, the x squared and the a squared are going to be together because it's horizontal for the 2a. Horizontal means x. The x squared and the a squared are going to be partnered together. So if 2a is 16, if 2a is 16, what does 1a equal? Whoops, 1a is 8. And so a squared would be 64. Now, do they already have that in the equation? Okay, so what does that mean I'm missing? Now I can go to my formula chart and figure out what am I missing in this problem then. Here's an ellipse. It has the x squared over a squared of 8. So what am I missing? What's that question mark represent? B squared. We need to solve for b squared. And this is not right. This should be squared and squared. Those equations should be squared. Okay, we are missing b squared. That's what we are looking for. What is b squared? They say the eccentricity is 0.25. Is that a memorization word? No, what is eccentricity?
Look it up.
Look on the formula chart. Eccentricity is down here on the formula chart. The formula says it is C over A. And I don't know what's wrong with my deal here. Okay, so eccentricity is E equals C over A. I'm going to plug in what we know. The eccentricity is 0.25. We know that. That's the E. We don't know C, but we do know A. What was A? 8. So how do you get C isolated other than in solve here? Say with me, Alexander. What do we do here? Multiply by 8. Okay, what do we get when we multiply by 8? Do y'all know what that is? I can type in the calculator if you don't know. But I imagine a lot of you know. Here 4, it's not 4. 8 times 0.25. C is 2. Okay, C is 2. You'll always need C squared. Just plain out simple. So if C is 2, what is C squared? 4. All right, that means what? How do we get our B squared? You need to look at something. What do you need to look at? Formula chart. For what on the formula chart? The ABC relationship. So here's ellipse. Make sure you choose this ABC relationship. It says it is C squared equals A squared minus B squared. Okay, so C squared, here's what the formula chart says. C squared, it's right there, equals A squared minus B squared. We know what C squared is. What is C squared? Or we know what A squared is. 64 minus some number gives us 4. What does that number have to be?
60.
Not even gonna do it through the algebra. We should just know that. That's 60. You could do your opposites if you wanted to. You could do your insol, but it's 60. That's the answer. This one was correct only 27% of the time. Only 27% got this one correct. In a physics class, what? Another, I don't know. In physics, a force diagram is used to show the effect of all the different forces acting on an object. The diagram shown represents the force acting on a child sliding down a slide. What is the magnitude of the resultant vector represented by the force acting on the child? All right, what type of problem is this one? How'd you know vectors? Does it say the word vector?
It does.
It does right here. And also not only that,
The arrows.
we see arrows. So this one, they already gave us the diagram. We don't need to draw a diagram, but I do need to draw the tic-tac-toe chart. I'm gonna make, since I have extra space, it's always on 4 columns will do enough for you for this test. You can always get away with 4 columns, but this one won't be just 3 across the side, because how many vectors do you see? 3. So I'm actually going to need an extra one. It's for vectors 1, 2, and 3, then the resultant. So remember, across the top, we always say x, y, h, and beta. And then down the side, we'll have here vector 1, vector 2, vector 3, and our resultant vector. I'm going to name these vectors over here. That's going to be vector 1 for us. That'll be vector 2. This will be vector 3. By the way, the data on this problem is that 47% of students got this correct. Okay, let's talk about vector 1 here. When you look at—
Good morning, Raider Nation. Pardon me, this interruption. Teachers at this time.
Well, I lost with the announcement where it was. So here we go. Vector 1. When you look at it, does it look like an X, a Y, or a diagonal H? It looks like a diagonal H. However, the data they gave me, they did not give me the diagonal magnitude and the angle. What did they give me instead? I wouldn't call that a resultant. This 55, what does that represent? They gave us an X. Now, if I just put it in as a 55, it's going to be wrong. Why negative 55, George? It's going to the left. Good. That's actually negative 55 because it's going left. Okay, what about the 70? Do I need to make that negative? Why positive? Because it's going up. Good. Let's go to vector 2. On vector 2, what about the 6? Positive or negative 6? What about the 8? Okay, let's go to vector 3. Now this one looks like a Y. The whole way it looks like a Y. So that means the only value they give us is a Y. You're saying it's negative. Why is it going to be negative? Going down. Negative 220. What do I put for X? 0, because it's perfectly vertical. Okay, so what do vectors always do? Add. We're going to go to the calculator. We're going to add them. And they said the word resultant. I'm going to slide it over now. Resultant. It said vector, so that's how we knew it was a vector problem. I'm going to now find the resultant. You know what? We don't even, let's save ourselves times. What's negative 55 plus 6? Let's just go ahead and fill it. Why are we using the calculator for basic math? Negative 49. This one's maybe not so basic. Let's just type that in. 70. Well, it's going to be 78. 70 plus 8 is 78, and then minus 220. What do y'all get when you do that? Negative 142. All right, great. Now, is that what the answer is this time? That's the resultant, by the way. An X and Y? Nope. Component form is another name for that. Component form. That's not what they want. They want here the, where is it? There it is. Magnitude. What does magnitude mean? The hypotenuse, which is the same thing as the radius, which is the same thing as the magnitude. All those are mathematically the same. We need to find out. How do I get that in the calculator after doing a bracket? Negative 49, comma, negative 142. How do we, whoops, negative 142. How do we make the calculator change an X and Y to an H and theta? Menu. Which one says vector? 7. And look for vector again. See? And which one says polar? 4. And hit enter, this gives you the h and theta. By the way, if you ever forgot this, just remember your formulas, you can always solve. X squared plus y squared equals h squared. Now we'll give you h as well. I'm getting 150.2. 150.2 and an angle of negative 1.9 radians. So the answer is C. Number 25, an airplane took off from the runway and reached an altitude of 1,200 feet after it had flown a distance of 6,000 feet. If the airplane travels at a speed of 306 feet per second, which set of parametric equations model this airplane's rotation? All right, there are two different sets you could do of ways to solve this problem. When you look at the diagram, what does it look like? Okay, there's more of you than just one. What type of problem does it look like when you look at it? It looks like a triangle. However, it says parametric as well. So we can solve it one of two ways. Okay, the first one I'm going to do is off of visual. What are we supposed to find? The x and y. Okay, they gave us 6,000 feet, 12,000 feet. Now that's how the plane's actually moving over time. So what we could do is to find this equation. This is like the simplified version of, like, if I broke these down to smaller values, it'll be a ratio. Now, what is the ratio between this is the y and this is the x? What is that ratio if you divide it out, like if you simplified it? Well, you could simplify it and determine your equation pretty quickly. What happens if you divided each of these numbers by 10? What y value you get if you divide both by 10? I'm going to call it y with a little 10 here because I'm dividing by 10. What's the y value? Divide that by 10? 120. Not I didn't divide by 100, just by 10. And then if I divided the x by 10, I'll do the x on top. 600. Now, do you see that value anywhere? No, but I can see which one's going to be the right one. What if I then came back and divided this by 2? What if we divided each of these by 2? We've already divided by 10. What if I now divide each of these by 2? What do you now get? 360. Yeah. So by ratio, which one should be the correct answer? C. Looks like it's going to be the correct answer. Now, that was using a triangle. Did I choose the wrong one? There we go. Sorry. This was only selected correctly 48% of the time. So that's one way of doing it, just by ratios. I did it by ratios there. They gave us the x and y equations. So that's why I did ratios of x and y. That makes sense how I did that? Just kind of looking at ratios. Okay. Now, another way you could do it is by parametric. They say the plane is moving at 306 feet per second. Now, which one's actually the plane? Is it the x path, the y path, or this h path? This is 306 feet per second, which means 306 feet every t seconds. So you just you multiply it by t. Okay, you with me so far? Is this an x, a y, or an h? H. Now, if you want to do it this way, what I would do is if I had to find the x, now what's the relationship between x and h? Is it sine, cosine, or tangent? Which one deals with x and h? Cosine. You could do cosine theta equals x over h. Now, right now I'm looking for the x equation over 306. And this would be a t, honestly, because it's feet per second. I could do it like this. Now, the angle, I would have to do an inverse tangent to figure out what that angle is. Let me do an inverse tangent real quick. So I'm showing you another way of doing this. It would be 1200. Sine is y, cos is x, tangent is. So I'm doing the y divided by x here. You could do it this way as well. 6,000, press enter. That's my angle. So I'm going to plug that in right there. So the last thing to get x by itself, you could insolve this. I'll just insolve it. Menu 3, 1. I'm going to say it's a cosine. Here's my angle. Right there, I'm going to put my angle in. Cosine equals It's the x value over the h, which the h they gave us is 306. Now, if I do this, press comma x, look what number they give me. It's the answer. What do we get? 300. All I did is I took the cosine of the h. Okay, and the only thing different would be to find the y equation. What would you do differently when you insolve? You would do a sine. Sine would be y over the h of 306. So if I just did the same thing again, but change this to a sine, sin, you could also do it like that and get 60. So there's multiple ways of doing this problem. You could use your sine y, cos x, tangent y over x. You could do it like that. Either way, that's how you solve this problem. The one other way I hadn't shown you is you could do Pythagorean theorem to figure out what this is and divide it by 306 to see how many seconds it took the plane. Once you figure out how many seconds, you could divide that out. You could do it that way as well. So there's a lot of different ways to solve this problem. Just pick one of them. But if you use a formula, you should be able to come up with an answer. Number 26, Harrison walks to the library after school every day. When Harrison leaves school, he walks 16 blocks due west and then 12 blocks due north to get to the library. What is the magnitude and direction of the resultant vector? All right, Brian, what type of problem is this one? How'd you know vector? It says vector on it. Very good. Let me copy my list here. I lost my list. Okay, it is a vector. So if I do a vector here, they didn't give me a drawing. I'm going to do a drawing and a t-chart. So go ahead and do this, please. Add it on your packet. And they only said 2 directions, so it should be a standard 4x3 here. Shouldn't be anything more than a 4x3. They do use the words northeast, southwest. So where do I put north? Top. What goes on the right? South, west. And over here, I'm going to do x, y, h, theta. And we'll have vectors 1, 2, and r. Vector 1, I'll change colors and do 2 in blue, and then our resultant I'll draw in black. So 1, 2, r. Okay, Harrison leaves school. He walks 16 blocks due west. Which way is that vector needing to go if it's due west? To the left. So I want to make a vector that's 16 to the left, and then 12 blocks due north. Now, do I angle it towards the end? It says due north. What do you think? Sergio, what do you think? Do I angle it to the north if it says due north? Yeah. No, you're gonna go straight up. If it says due north, it means north from that spot. So due north. And this one's 12, so this needs to be shorter. I'm off here. Whoops. This one needs to be 12. And you go down more than that. There we go, 12. All right, well, let's put the resultant vector on there, because that's what the drawing's missing. It needs a resultant. There it is. There's my resultant vector. If I haven't said it already, the students only got this right 40% of the time. Okay, let's fill in our chart. The first vector, this 16, is that an x, a y, or an h? X. So good. Y negative? Going to the left. Okay, and I put a 0 because it's flat. Okay, what about the second vector, the 12? Pedro, what do you got on that one? X, y, or diagonal h? Y. Positive or negative 12? Okay, that's going up. What do you put for the x? 0. Okay, let's add these up. You always add up vectors, and the x's and y's are what you add. You don't add h's, you don't add thetas, you add x's and y's. So what's negative 16 plus 0? Negative 16. This vector moves left 16, the resultant, and then 0 plus 12 is 12. It goes up 12 units. That would be the vector. Actually, I did a point. I should do a vector bracket like that. That would be the resultant vector right there. Now we need to find the magnitude and direction. So how in your calculator do you make the I'm just going to do control left parenthesis to get the bracket. How do I make it give me the magnitude and direction? Sergio, do you remember what to press? That's right, it's going to be C. 4. Okay, our answer is 20, 2.49. 20 and okay, now this might be the one time you want to change modes, maybe. It says the answer is 2.249. I better put the 8 because I can't round it. Excuse me, not 249, 498. 498, but this is in radians. So when I look at my answer choices, I do have 20 blocks, and then over here I have 28. So those are out. But do I know which angle it is? No. So the radians doesn't really help me. You can do one of two things. It might be easiest to say, what's the angle from here to here? That would be a reference angle. So I have a y, I have an x. Which trig function uses y and x? Tangent. I'm just going to do solve tangent, menu 3-1. Sine is y, cos is x, tangent is. So we don't know the theta. I'm going to put theta there, and I need to put a degree symbol. Why am I putting a degree symbol? Because I'm in radians and I want the answer to be degrees. So I'm going to do tangent theta equals, what's our y? And what's our x? -16. And so the answer is, I'm going to do control, comma, theta. What is our angle here? What are y'all getting in degrees? -36. Now remember, it's negative because it's coming from 180. So this is like 0 degrees. This is 180 degrees here. And this is 360. So it's negative, which means you could add it to 180 to find out what the angle is in standard position. It's 143 degrees this way. It's 143 degrees this way. 143.1 degrees. Inside here, it was the 36.9 degrees there. Now, which way is the answer written in? From the north. Remember, vectors can come from anywhere. The north, it's coming from the north here. We got to find that angle. How could I find that angle? Multitude of ways now. How much to the north to the west? How many degrees is it north to west? 90. So you could take your 36.9 that are here and take them away from 90. So we could just do that. So 90 and then minus that 36.9, 53.1, and that would be the answer there. 53.1 degrees. You could do it that way. Okay, now a quicker way we probably could have done it. We haven't changed modes this whole test. This might be the one time you make an exception and change the mode, and where we first started with the vector. If I would have changed it to degrees, you see I would have given me that number. Now that's from the east. How many degrees is it east to north? 90. So since this is starting, these answers are starting at 9, you could have just taken 90 away from that. 143 minus 90 and gotten your answer as well. That might have been the quickest way, but that would have required changing of modes. Okay, so there's different ways of doing that problem. 27, vectors U and V are shown. Which representation shows the vectors of U and V to create vector W? Now, which type of problem is this? It is a vector. So I don't have my list copied anymore. Let me copy this. This is a vector. And what are we supposed to do with these two vectors? Yeah, so how do you add vectors up? Tip to tail. By the way, this one was selected right only 44% of the time. So it needs to be tip to tail. So this vector goes 4 to the right and 2 up, and I'm just going to add V to it. What does V do? How many to the left? Yeah, count how many units left? 3 left, and how many up? 1. So I'm gonna draw it on my own over here. It needs to go 3 left, 1, 2, 3, and 1 up. And then you need to have a resultant. So you're looking for a vector like this. Now they don't have to go in that order, but that would be U, this would be V. You need to have this resultant that goes 1 right and 3 up. Which one has a resultant that goes, or which one has that drawing? C. C is the correct answer here. Like I said, it's only chosen correctly 44% of the time. Most students chose A. Again, what did they do wrong on A? They didn't go tip to tail. What did they do? Tail to tail. This one, A was selected 42% of the time. So how many should I say got this right? 44. Almost as many people chose tail to tail as opposed to tip to tail. Just remember how to graph vectors. Tip to tail.